Okay, in 11.4, the topic that we're looking at here is arcs and chords. And so there are a couple of theorems that we want to look at. Here's the first one. It says if a radius is perpendicular to a chord, remember that's the symbol for perpendicular, then it bisects the chord and the arc. Okay, so we're going to read through both of the theorems and then I'll show you what they say, what they mean. Okay, so if a radius is perpendicular to a chord, then it bisects the chord and the arc. The next one, in a circle or congruent circles, if two chords are equidistant from the center, then they are congruent. So let's analyze these one at a time and see what they're saying. So the first one, if a radius is perpendicular to a chord. Okay, so a radius would be originating from the center of the circle. And if it's perpendicular to a chord, remember, what's the best way to know if it's perpendicular? It's got a 90-degree symbol right there. So if a radius is perpendicular to a chord, then it bisects the chord. Remember what bisect means. Cuts it in half. So in this case, if this one is 5, the other half is 5. But it not only bisects the chord, but it also bisects the arc. It cuts the arc in half, right? The arc that the chord goes to. So if this half is 40, the other half is 40. Or if the entire arc is 80, it splits it in half to 40 and 40. If this entire segment is 10, it splits it in half to 5 and 5. So when does that occur? When the radius hits the chord perpendicular. It cuts the chord in half, it cuts the arc in half. All right. The next one says, in a circle or congruent circles, if two chords are the same distance, equidistant means the same distance away from the center, then they are congruent. So in other words, if this chord is 4 away from the center and this chord is 4 away from the center, then those two chords have to be congruent. They have to be the same length. So that's what these two theorems are saying, and we're going to use these throughout this section to answer some questions. All right, so let me kind of give you an example of the type of problem that you might be looking at. All right, so here we're given 4 pieces of information about this circle. The measure of arc BC is 22. The measure of arc BC is 22. GH is 8. GH is 8. Okay. BD is equal to GE. BD is equal to GE. Okay. And HA is equal to 6. All right. Now, let's think about some of this stuff. Okay. Now, for the first thing that I can look at is that, remember, if the radius is perpendicular to this, then what that means is that these two are the same, right? And then the same thing here. If this radius is perpendicular to the chord, then it cuts the arc in half. So if that's 22, this is 22. All right, now, here's the next thing that we want to look at. Okay, remember, it says that BD is congruent to GE, right? So if this is 8 and 8, then this one's got to be 8 and 8. And likewise, if this is 22 and 22, then this has got to be 22 and 22 because they're the same length, right? And so if these two are the same length, they've got to be the same distance from the center. So if this is 6, then this has got to be 6. So you see how we kind of filled all that in just from that information? And so from here now, we should be able to just look and see what the answers to all these questions are. So what's the measure? And remember, get your notation correct. This is an arc. What's the measure of arc BD? The measure of arc BD. So where is BD? So BD is from here to here. What's the measure of that arc? Well, it would be 22 plus 22, which is 44. All right, so what's the measure of arc GF? GF is from here to here, and so that would be 22. What's the measure of arc GE? GE is 22 plus 22, which is 44. What's the measure of arc CD? CD is from here to here, it's 22. Okay. GE, the length of GE is 8 plus 8, which is 16. The measure of segment BD, the length of BD is 8 plus 8, also 16. DI is from here to here, it's half of the 16, which is 8. And AI is from here to here, which is 6. All right? So based on those theorems, if you get some measurements, you can fill out all the rest of those measurements as well. Okay, so some more practice problems for us now. Okay, so let's say we have a problem where it says the radius of circle A is 13, BD equals 10, find CA. So let's plug in the parts that they've given us. The radius of circle A is 13. All right, now here's the deal. If the radius of circle A is 13, here's what we want to look at. Okay, first of all, I can draw in any radius I want, and it would be 13. This will be 13. This could be 13. This could be 13. This could be 13. Okay, but I want to draw in the radius that would actually help me solve the problem, and that's the one that creates a right triangle right here. How long is it? 13. Okay, so I need to draw in the radius that makes a right triangle. And BD is 10. That means each half of this is 5 and 5. Why? From the theorem that says if the radius hits the chord perpendicular, it's got to cut it in half. All right? So what are we trying to find? We're trying to find CA. So this is the part that's missing. How are we going to do it? Now you should be able to see that we can just use A squared plus B squared equals C squared. All right? Which one's the hypotenuse? The hypotenuse is C, which is 13. So I know that when I write it in, it's going to be X squared plus 5 squared equals to 13 squared. The hypotenuse is always C. And so when we take that and we can move this over to the other side, and it'll be like X squared is equal to 169 minus 25. 5 squared is 25. X squared is equal to 144. Then we take the square root of both sides, and the x is equal to 12. So that means that CA is 12. That's your answer. All right. Next one. Okay, so the radius is 40. AC is 32, so 32 goes here. Find BD, which is all the way from here to here. So if we can, again, draw in this radius that makes a right triangle here with 40, if I can find this length, I can then use that to get BD. So once again, we'll go X squared plus 32 squared equals to 40 squared. All right, so that's going to be equal to 40 squared. Let's see what that is. 40 squared. 40 squared, 1600 minus 32 squared, 1040, or 1024. Okay, I need to subtract those from each other. $1,600 minus 1024 is 576. Then I'll take the square root of both sides, and I'll get the x is equal to 24. Now that's not the answer on this one. Okay? Here's the reason why. Because remember, we just found 24 to be from here to here, but what do they want? BD, which is all the way across. 24 plus 24 makes 48, the actual correct answer. All right? So there you go.